So continuing on with another thing that might look kind of new, now we're going to make another set of deviation scores, which is each person's total deviation minus their treatment deviation minus their subject deviation. So we would take this one minus this one minus this one. What we're doing is getting what's left that we haven't computed so far, and that's what we're going to use as our error term or within groups sum of squares. So for everybody in the study, I want you to try this. For the first person, it's negative 2.267 and then minus a negative 0.267 and then minus a negative 1.9337. If you did that right, you'll get negative 0.0663. Remember, subtracting a negative is like adding. Then square it and you get 0.0044. Do this for everybody. So you're going to make deviation scores within, pause the video, see if you get it right, and also make the squares within, pause it and see if you get them right. Do both of those columns and then unpause. And if you got it right, you can do an accuracy check. Let's see, do they add to 0? Yeah, there's a little rounding error, but yeah, they add to 0, pretty much. And when you add up squares for these residuals, deviations, it's 51.2. This is what we're going to use as sum of squares for error. It's a reduced within squares, sum of squares, because we whittled away personality-related variability and tossed it out. So now figure out degrees of freedom. Between groups is going to be just like a between groups Anova, between treatments, number of groups minus 1. And for degrees of freedom within, for the error term, I want you to take number of groups minus 1 times number per group minus 1. Pause the video now, see if you get it right. And you should be doing for within groups, 3 groups minus 1 times, there were 5 in each group minus 1, so it should be 2 times 4, which is 8. And degrees of freedom between is 2. And now make mean squares between treatments, which will be sum of squares between treatments, this here, over degrees of freedom between treatments. Do it now. Pause the video, see if you get it right. And if you get it right, there you go. And now make mean squares within, where you're not using this orange one. This one we're tossing out. You're using this purple one, this reduced sum of squares within, or sum of squares error. So take this sum of squares over 8, over degrees of freedom for error, to make a mean squares. Pause the video, see if you get it right. And you should get 6.4. Now I want you to make F obtained, which is going to be mean squares treatment over mean squares error. So you're going to use in the denominator this reduced mean squares that we just did. Pause the video, see if you get it right. And if you did it right, 29.07 over 6.4. 4.541. Now, pause the video and look up F crit at an alpha of 0.05 using the degrees of freedom you just computed. And if you did it right, you should be looking under 2 and 8 degrees of freedom, and it's the 0.05 alpha or P level, so you want to look at the bold number, and the F crit that you will get is 4.46. Now, pause the video, draw the graph with F crit and F obtained, and decide if you can reject the null, and then unpause and see if you got it right. So if you drew it right, you have F crit of 4.46, and over to the right of it, you have the F obtained or F treatment of 4.5. So yes, we can reject the null. Now we don't yet know, or do we? We know that one of the drinks is different. Do we know which one? Pause the video and decide for yourself, and then see if you got it right. And the answer is we do not know. Just as with the between groups Anova, you get an overall or omnibus significant F-test, we still need to do follow-up tests using coefficients to tease apart, well, exactly which mean or means differ from the other or others. So I want you to sort of think about this concretely. Let's sort of scroll up and look at our means here. What do we and don't we know if all we've done is the overall omnibus F-test? Well, cod liver oil had a really low mean of 1. And grapefruit juice, it was 3. We don't really know if those are significantly different. Cola had a real high mean of 5.8, so of course that's going to be different from cod liver oil. But we don't know if cola differs from grapefruit juice, or if cod liver oil differs from the mean that's next to it, grapefruit juice. So we would need to use coefficients and do follow-up tests for that. Now for the next part of our assignment, I'm going to ask you to redo, using this data, the same study, but it won't be within subjects Anova. I'm going to show you how to set it up here. We're going to use the same data and do a between subjects independent groups Anova, just like the first kind of Anova that you ever learned in this class. So we'll get rid of means for people, and we'll get rid of this where it says participants, because it's no longer Fred that got 3 treatments. One guy got grapefruit juice, a different guy gets cola. So the grapefruit juice group is 5 people, and then the cola group now is entirely different people, unlike with the repeated measures design. We're going back to where people are in different groups now. But the means will stay the same, they're already computed. But here's the thing, if we don't take repeated measures, we can't do this thing over here in orange and this thing in purple. We can't really have a way of computing personality or subject variability and tossing it. So let's just get rid of these computations because we're changing this over now. If I gave you a homework assignment for this, I'm going to ask you to do these computations for yourself, and I'm just doing this to get you started and so you know how to set it up. You're doing the same analysis for between groups. So I'm going to relabel this now. Let's relabel it a between groups or independent groups Anova. And you already know how to do this, so I want you to just run the whole Anova and decide what the result is, because that's going to be, if I gave you homework, what you're going to enter for your homework. So let's see. Let's put all group means just so we keep everything nice and straight. So we'll put those in this column here. So the people who drank grapefruit juice, their group mean was a 3. And then other people drank cola, and their group mean was a 5.8. In fact, over here on the left, we really ought to get rid of this, right? Because it's no longer that Fred, Sid, Sally, etc. got, repeated treatments. Now that we're doing a between groups design again, these are completely different people in each group. So the people who had grapefruit juice were Allie, Bob, Charlie, Dan, and Ellie. And the people who got cola were Felicia, George, Harry, let's say Anise, and Jack. And completely different people got cod liver oil, now that we're changing the type of design. And their names were, let's say, Kelly, Lori, Melissa, Nancy, and Ophelia. Okay, so the group of people who sipped cola, their group mean was 5.8, so you put that for each. And the group of people who sipped rancid cod liver oil, their group mean was pretty low, 1. Now I want you to make deviations within, which you already know how to do. It's going to be this person's score minus their group mean. Do it for the whole column. Pause it, see if you got it right. Do your accuracy check, which you know how to do. And then make, in the next column, the squares and see if you got them right. Now, we're not going to toss it. We're